Hello, Math 1224. This is Dr. P with Lesson Launch 601 to Infinity and Beyond. I want to start by asking you the following question. So consider the function f of x equals 1 over x squared. I've sketched a graph of it here, which I have to say came out pretty good considering I'm doing this on a tablet. Anyway, so suppose I gave you this function, and I asked you, what is the area under this curve from x equals 1 to infinity? In other words, what is the total area of the region under the graph above the x-axis to the right of the line x equals 1? And you'd probably say, that is a very strange question, right? Because this area is unbounded. It goes on to the right forever. And it's very unclear how we would find the area of something that doesn't have any boundaries. I mean, we've talked about in this course how to find the area of something that has a curvy boundary. That is something that we can use integrals to do. But we've never talked about how to find the area of something that goes on forever, that has no boundary on the right side, and that is infinitely long. So how would we answer a question like that? Well, the way that we answer this question is the same way that we answer a lot of questions in calculus that are about infinite or infinitesimal things, which is that we use limits. We use limits to answer these questions. So in particular, the way that we will answer this question is we'll say, okay, maybe I don't immediately know how to find an area that's infinite, so I'm going to scratch that off for now. Instead, I'm going to work on a problem that I do know how to solve, which is, how do I find the area under the curve above the x-axis between x equals 1 and x equals, let's say, b, where b is some finite real number greater than 1. How do I find that area? And you probably know by now, the way that we find that area is we calculate an integral. In this case, we calculate the integral from 1 to b, where b is that real number, of f of x dx. So in this particular case, that would be the integral from 1 to b of 1 over x squared dx. And we can evaluate that one using the power rule. Power rule says that the antiderivative of x to the minus 2 is, let's see, that's 1 over negative 1 times x to the minus 1, evaluated at 1 and at b. Then we subtract. Let's see, I'm just going to simplify that a bit. Feels a little bit friendlier that way. Anyway, I'm going to get negative 1 over b minus negative 1 over 1. So what does that come out to? That comes out to, I think that's just negative 1 over b plus 1 if I simplify all that. So that's 1 minus 1 over b. Okay. Now remember, what is the question we were answering? The question we were trying to answer there, let's zoom out a bit. The question that we were trying to answer is, what is the area of this region, the region between the curve and the x-axis from x equals 1 to x equals b? And we've said that that area is 1 minus 1 over b. Now think about what happens if we let b go to infinity. Okay, now let's think about how this quantity here, 1 minus 1 over b, varies as we change b. If we were to increase b, then that increases the denominator of this, making this a smaller fraction, which means we're subtracting from 1 a smaller amount. So in other words, as b gets bigger, this quantity is going to get nearer and nearer to 1. It's going to increase towards 1. So if we take the limit of all of that, if we take the limit as b goes to infinity of the area from 1 to b, then we get the limit as b goes to infinity of 1 minus 1 over b. And I hope that you know enough about limits to say that that limit is 1 minus whatever 1 over b goes to as b goes to infinity. Well, that's 0. So that limit is 1. So what we've just given here is an argument that the area of this region, if we let b go to infinity, is going to approach 1. So what we can say then is if we sketch out the area under the curve from x equals 1 to infinity, well, no matter how far we let that extend to the right, that area is never going to get bigger than 1. So it's never going to get bigger than 1. And in fact, it is approaching 1. It gets as close to 1 as we like. So for that reason, we say the area to the right of x equals 1 is 1. And another way of saying that is that the integral from 1 to infinity of 1 over x squared dx is just 1. So the main idea of this section is that we're going to calculate some integrals, some of which are taken as the limit of the integral. The left-hand or right-hand limit goes to either minus or plus infinity. Sometimes we'll do that. Sometimes we're going to work with functions. Sometimes we'll work with integrals that are definite integrals over finite intervals. Interval, it's hard to tell apart. They're over finite intervals, but somewhere in that interval, this function has a discontinuity, and the function value might go to infinity. We'll deal with that case as well. And we're going to find that in each case, the key to giving coherent answers mathematically to these questions, what is the integral, is to take a limit, some limit or other, based on the situation we're looking at. So anyway, this is an intro. In the next video, we'll talk about a couple of different cases of improper integrals. That's what these are called, by the way. I don't know if I ever mentioned that, because I sort of started with a question and then answered it rather than saying what topic this is about. So any integral that involves infinity in some way is called an improper integral. And that is the topic of this next section. So in the next video, we'll unpack that a little bit. Thank you.